Hi, everybody. Can you hear me?
Hello everyone, welcome.
Okay, thank you. So for today, we have prepared in partnership with Delfos, a really important presentation. It's a really trending topic about hybrid plants, how to be done right. So today, we are going to talk about how to design and operate solar plus BESS systems. But before starting, we are going to give some couple of minutes and to everybody get connected to the live webinar. And it's really interesting for us that more than 300 people are already joined this webinar. So it's like a signal from the market that like the energy industry is really interested on this topic. So today we are with Lucas. And Lucas, how are you?
Hello Alejandro, I'm fine, thanks. I'm very excited to be here to discuss this topic and let's do a great webinar, right?
Yeah, it's gonna be really interesting. And before starting our webinar, I just want to make a small discussion. What do you think about the global market of BESS systems?
Interesting question. I see that 2026 is going to be a very promising year for the BESS market. I believe it will continue to grow and we'll continue to see this momentum not only for utility scale BESS, right, but also for distributed storage solutions. So I think it will be an important year for consolidation in some markets as well as new ones that are advancing.
Okay, got it. So just to complement your answer, from my perspective, like I've seen like this kind of assets is not becoming just a complementary asset to the PV solar systems. It's also is becoming like compulsory. Like we've seen like in some countries, BESS systems are becoming like a compulsory asset to become like the grid more robust, more flexible. And it's not just like an optional asset, it's becoming like the backbone of the grid infrastructure. So we have seen it in our customers, like the interest in BESS is increasing highly. So now to start, today we have a presentation with Delfos. So hybrid plants done right, designing and operating solar plus BESS. So it's not just a point of view from the technical point of view. So how all this information is going to be translated from the KPIs, also from the revenue point of view, not just looking at technical decisions on how all these decisions is going to impact in our KPIs and also in our CapEx and ROI. So to start, so today we are, my name is Alejandro Fraga. I'm technical advisor at RatedPower. So I'm supporting the Latin and Brazilian markets to help you out how to use our software, RatedPower. And Lucas, welcome.
Thank you, Alejandro. I'm Lucas Tavares. I'm a Renewable Energy Specialist at Delfos, and I'm here also to contribute on the topic.
Thank you. And for those who may not know us, RatedPower is cloud-based software, and we are the smartest way to design utility scale solar PV plants. And we are not just in PV plants, we are also offering solutions to help developers, IPPs, and EPCs to make better decisions early in the project lifecycle, including BESS and standalone systems, just to make easier the choose of what kind of PV plant is going to help you out to accomplish like your business model. And Delphos.
Yes, Delfos help operators and asset managers identify underperformance and failure risks early on across PV, wind, storage, and also hydro portfolios, reducing energy losses and increasing revenue. We do this through our intelligent asset performance managed platform that monitors over 15 gigawatts worth of renewables worldwide. So that's our background.
Thank you, Lucas. So for today, we have prepared the following agenda. There are five main points. And the structure is going to be the following. So just to everybody have the same context, we're going to have like a small introduction about BESS, what BESS really is. We are continue going to design our solar plant plus BESS, and how RatedPower is going to help accomplish your goals about good performance solar plant plus BESS. Then we're going deeply to operating a solar plant plus BESS with the help of Delfos. And then we're going to sum up all this information, and we're going to show you like the main strategies for ROI maximization, taking into account designing and also the operation part. And finally, we are going to a Q&A session where we are going to be open to answer all your questions. And, and now we are going to launch a poll in order to know your attendees, like in what process of the design you are right now. Are you in the designing process, or you are already operating um, assets related to solar panels plus BESS? And we just want to know this in order to address our presentation to directly to our community. So the poll is going to be closed just in 1 minute, and we are just going to see the results and share the results with you. Just 30 seconds more. We already have more than 50 answers. Okay. Uh, so we are seeing like a trend in our answers. 70% of the people is during the design and development phase. That's really important for us, and that's really glad for us, because we are going to help you from the designing um, how to do it this more efficiently and faster with RatedPower. The second answer is 20% of the people now know I'm new to hybrid plants. So that's why we are going to do this introduction to BESS. And a small amount, 10% of the people are during the operation phase, and just 6% no, but I work with similar assets. So now we can close the poll. Thank you for everybody who has participated. And we start with the introduction with BESS.
Okay, perfect. So we've seen that most people are familiar with hybrid system, right? But also a few that maybe are not. So it's important to have this intro just so we're all on the same page, right? So what exactly is BESS, right? At its simplest, a BESS is a complex assembly of battery cells integrated with power conversion systems, and most importantly, an energy management system, the EMS. The BESS takes the intermittent wild energy from your solar panels, for example, and turns it into a firm dispatchable asset. However, a BESS is not simply storage. It is an asset constrained by power, energy, degradation, grid limits, and market conditions. So every operational decision has a direct impact on long-term value. That's why it's so important to make good decisions from the start. In that sense, we often see assets fall short of their expectations due to a lack of dispatch strategy, a design that is disconnected from the operation, so that's mostly why we're here today. Also due to CapEx-driven decisions, which sometimes can result in higher lifetime costs, poor performance, and safety risks, as well as sometimes unrealistic operating assumptions. However, if done correctly, BESS has the potential to deliver many benefits to a PV site. And these benefits, they go well beyond addressing these failures or these challenges that we mentioned. When properly designed, operated, and monitored, BESS can play a key role in grid stability, uh, as we can see in the next slide. Also, this is done by providing fast frequency response, peak shaving, and ancillary services. At the same time, it often can improve the revenue streams through energy arbitrage, capacity markets, and grid services, turning storage from a risk-prone asset into a strategic and profitable enabler of a more resilient power system, as Alejandro mentioned in the beginning, right? It's not just now an add-on, but something that is crucial and very strategic to the power system. This is why we're here today. Our goal is to discuss the best practices and strategies for maximal ROI in hybrid BESS plants, so you are able to avoid common pitfalls. Now, Alejandro will continue discussing aspects of sizing and design. I'll return later on to discuss a bit about the operation.
Yes, Lucas. As Lucas said, it's not a common asset. BESS is a really important asset to size because it's going to last for the next 25 to 40 years. So to understand where design decisions matter, it's useful to step back and look at the full project life cycle. So in the early stages, we we can see like in the first 3 to 18 months, we are going to take the best decision. It's not about choosing the best equipment and also the most efficient. It's about aligning the strategy with our business model. That's why the decisions taken here about which equipments I'm going to use, what's going to be the design, and what's going to be the size of our equipment is going to last for the next 25 to 40 years, the operation stage. So that's why it's really important that the decisions taken here, because it's going to matter for the next 25 to 40 years. So now going deeply, uh, these decisions are going to be aligned to a strategy. So first of all, I'm going to choose what's going to be the objective of my best system. Are we going to do an energy arbitrage? So I'm going to buy low cost energy and then I'm going to sell it back to the grid for higher prices. We're going to back up the grid to make some frequency regulation? Or are we going to recover some energy from curtailment? Or are we going to shave our peak of consumption? So depending on the answer of, of these questions is going to be aligned our strategy. And every of these objectives is going to be aligned also to one kind of revenue. So depending on the answer of these questions, we are also going to align to a connection strategy. So we are going to see two kind of connections. We are going to see BESS systems DC coupling and also AC coupling. So what's the difference between both? So after settling like the right objective of our BESS systems, we have two kind of connections. It's not just about comparing which one is going to be best for my system, for my solar plan and my business model. Both are okay. It's not one is going to be better than the other one. It depends how it's going to be aligned to my strategy. So just overall talking, in this coupling, we see that is a more simple connection. Here we just see one inverter. In AC coupling, we see like two different inverters. So overall talking, we can say like AC coupling is more complex. And being more complex, normally AC coupling is going to be more costly as well. Additionally, here we can see like the battery is going to be connected also to DC bus. So it's going to give us some advantages and some disadvantages. An AC coupling, we see our second inverter or rectifier is going to be connected to the AC bus. So then we can get energy from the grid. We can also connect our batteries and get energy from the grid. And this energy can be used for energy arbitrage. So we can buy it for like lower cost, lower price, and we can sell it back to the grid for higher prices. So both both infrastructures, not is not one is better than the other one. So they just have different objectives. So all these difference can be seen also in the efficiency. For instance, here having two different inverters, so overall, the efficiency of AC coupling is going to be lower. But we are also have more flexibility, because we can charge the batteries from the grid. Here, charging the batteries from the grid is going to be more limited. It's going to be limited. So it's not one is going to be better from the other one. That's why we're in the next slide. We're going to see how we are going to align our revenue strategy according to every kind of connection. So depending on how my business model is made, where I want to get the money from, so I'm gonna align also the connection strategy with my revenue strategy or my revenue stream. So if I want to make the most of my PV plant and take the best the make the most of my PV system, so I want to recover some clipping, also recover some curtailment. So DC coupling, it will be okay. It will be stronger than AC coupling. Why? Because my battery is gonna be connected to the DC bus, so then I can recover all the curtailment, also the clipping made by my made by the inverter. On the other hand, yeah, I want to do some energy arbitrage, peak shaping, demand charges, PPI firming and shaping, also ancillary service. So AC coupling will make more sense because I can buy energy from the grid, sell it back in better prices. Also, it's going to work as a backup from the grid, so it can regulate also the frequency of the grid. So it's going to give us different sources of revenue compared to DC coupling. So it's not about choosing which one is going to be best from the other one. It's about knowing that both are different, and depending on my revenue strategy, also is going to drive my coupling strategy. Additionally, this is why coupling decisions must be made with both design and operations at the table, because also maybe IC coupling, because it's more complex, also is going to impact to my operation strategy. So um, to see this and how to RatedPower is going to help us to choose which one is going to be most useful for my business model. We already settled a study case, so it's going to be located in Kent, UK. It's a real plan, but we want to do a disclaimer, like the information showing here is just for academic purpose. It doesn't mean that like the information shown is like the actual information of the plant. So this study case is located in Kent, UK. It's a PV plant of 380 megawatts peak, and we have also a BESS system connected to it. And the objective of these study cases is to see the difference between AC and DC coupling, and to see how RatedPower is going to help us to choose wisely, depending on the KPIs and results shown by RatedPower. So now I'm going to change. It's time to log in and show the results of our simulation. One sec. So here. So here we can see RatedPower software. As I already mentioned, is cloud-based software that allow decision makers to take decisions based on data. So here we have the AC coupling system and also the DC coupling. And the most important is that in real time and in really agile, with really small input data, we can have really high and really technical output data. So here we see like the 380 megawatts power solar plant. Here we have around 500,000 solar panels, and RatedPower is useful for simulate multiple designs on defined number of simulations with no limits. And all the information that we got from really small input data, we had power, also energy, financial information, um, information related to the BESS system, how the battery energy is going to be used, the number of daily cycles, the life the lifespan of this battery system, and the recovery curtailment. All this information is backed up by information really technical. So we have documents, we have also a power flow model, spreadsheets, drawings, and we have all this information is really technical that allow decision makers to do a due diligence of any project. So here we have an AC coupling, and here we have the DC coupling. We see the difference here. We have battery systems out of the available area for the PV plant, and here we have the DC coupling. And how rated power is going to help you to take a wise decision. So because we have a comparison tool where we have also the both designs, we have AC coupling in the 41 and DC coupling the 42, and based on information in our database of IRENA, and we can get also the capex. So we can see, like in this case, the AC coupling is going to be more expensive or more costly than the DC coupling, but also we are going to get the ROI. That's one of the most important indicators. Specific production, also LCOE, the time of payback, and all this information is backed up, but by really technical information. And if you want to make some changes, you clone the design, and here you can change in our tab the type of connection, the power conversion system that I'm using, the battery container that I'm using, the number of power conversion systems, our dispatch strategy, and also its backup. All the results got in this example are based on the prices of the UK, of the energy prices by 2024. It doesn't mean that the results are the real ones. It's just an academic exercise. And we see how rated power is going to help you to get like a wise decision. So here we can see, like in one of the documents that rated power exports, here we have like different kind of capex. In AC coupling, the capex is going to be greater than the DC coupling. Also, we are going to see the different ROIs, also LCOE, and how this information is going to be shown like in depth and really in detail to take a better decision. And if we want to go also to a summary of BESS energy results, here we have a summary energy report, and we can see how the battery is going to be charged and where this energy is coming from. It's coming from the grid, it's coming from the PV system, or it's coming from which one of both, and how the prices of energy is going to impact about the injection of this energy. Are we going to inject to the grid? Are we going to inject to the BESS systems, depending on these prices? So rated power is going to help you to choose these kind of decisions, how to make the most of the revenue in terms of my revenue strategy. So now we are going to the operating a solar plant plus BESS.
Okay, perfect. Thank you, Alejandro. Now we discuss the operation, right, which is the longer period in the asset lifetime, as you can see in the next slide. Yes, representing around 25 to 40 years. So needless to say that this is what makes it so important. Like Alejandro showed, when done properly, adding a BESS to a PV plant can increase the project's potential. However, it can also double the complexity of the operation. If you, next slide please. If you operate, yes, your hybrid system like a standalone PV plant, you're leaving money on the table. In a standalone PV plant, you usually track if it's producing. In PV plus BESS, you must track how it's behaving. Standard performance ratio won't be enough. You need to pay attention to more KPIs. And for that, we've selected here to share with you the most important ones. The next slide, we have a selection. The first one being the state of health. The state of health indicates the remaining lifespan and capacity of the battery. It represents what percentage of the original energy capacity can still be delivered. And why it matters? Well, it's a key indicator for lifespan and warranty compliance. A declining state of health signals degradation, helping you plan maintenance, augmentation, or even replacement before it impacts the operation. We also have round-trip efficiency. The round-trip efficiency measures how efficiently the BESS converts charging energy into discharging energy. It is essentially the percentage of energy out versus energy in. For example, if 100 megawatt hour is charged and 90 megawatt hour is discharged, the round-trip efficiency is 90%. And of course, a higher round-trip efficiency means more value per megawatt hour and fewer losses. If you have a drop in this KPI, it can reveal efficiency problems or component degradation. We also highlight here energy throughput that tracks the total amount of energy processed by the battery over time. For example, if a 10 megawatt hour system charges and discharges a total of 100 megawatt hour in a month, its throughput is 10 times its capacity. This KPI indicates system utilization and wear. And of course, higher throughput can mean higher revenue, but also faster aging. So that's why it's important to pay attention to it. We also highlight here equivalent full cycles, which normalizes all partial charge and discharge cycles into full cycle equivalents. For example, charging from 50% to 100% and then discharging back to 50% equals 0.5 equivalent full cycles. This metric provides a more accurate measure of battery usage and aging than raw cycle counts, especially for real-world operations where partial cycles are common. We also have avoided curtailment energy. Here you measure how much energy you saved from being lost during grid constraints. Of course, the higher the better, but again, also this is a KPI that is more relevant for DC coupled systems as Alejandro showed, right? So depending, of course, on your design, you also rely on different KPIs. And finally, revenue per cycle, which measures how much revenue the BESS generates normalized per cycle. As also Alejandro mentioned before, the type of connection is directly related to how you intend to operate your assets. So this financial KPI helps answer the question, are you cycling the battery for pennies in arbitrage while losing dollars in degradation, for example? If that's the case, then you need to rethink your operation, right? Additionally, it's essential to ensure BESS safety by continuously monitoring safety-related data and KPIs. Tracking failure logs, alarms, and operation condition metrics enables early detection of abnormal behavior and potential risks. At the same time, this data-driven approach supports performance optimization and helps secure a solid return on investment. For this, we highlight two very important tools in the next slide. The first one being the digital warranty tracker, a living document or dashboard that logs every time the system exceeds important limits, such as temperature, humidity, or energy limits. And why it matters? Well, you can keep track of this data on a monthly basis, right? You need to be aware of potential risks and abnormal behavior as soon as it appears. And also incident logs, an automated recording of thermal, voltage, or any other operational anomalies to enable pattern recognition and correlation analysis. This allows early identification of recurring malfunctions, support root cause analysis, and strengthens predictive maintenance and safety strategies. In the next slide, we'll bring here an example of a digital warranty tracker. Here, we're not only looking at KPIs like availability, state of charge or energy throughput, but also continuously monitoring the conditions that actually matter for warranty compliance, like room temperature, humidity, energy cycling, and operational limits. Every time the BESS exceeds a defined threshold, whether it's a temperature spike in the summer or abnormal humidity or excessive energy throughput, it's automatically logged, time-stamped, and contextualized with events and alarms. Over time, this creates a clear, auditable history that links operating conditions to performance tests, failures, and degradation indicators like delta SOH. Instead of debating months later whether a warranty condition was violated, you have objective, centralized evidence in real time. This is what makes a digital warranty tracker so powerful. It protects the asset owner, supports discussions with O&Ms, and turns data into accountability rather than just assumptions, right? Okay, now that we know which KPIs really matter, the next question is how to use them effectively. This is where data centralization becomes non-negotiable. You simply cannot manage 10 hybrid sites with 10 different portals, credentials, data models, and update cycles, right? Fragmented data hides some problems. Small efficiency losses, recurring alarms, minor availability drops, each one sometimes insignificant alone, but together they quietly erode ROI. Centralization puts everything in one place with a single source of truth, making patterns visible and turning unknowns into actionable signals. On top of that foundation, data-driven tools and insights are what transform monitoring into optimization. Centralized data enables analytics, benchmarking across sites, early warning indicators, and automated insights that support real operational decisions. Instead of reacting to alarms or monthly reports, operators can anticipate issues, validate operating strategies, and align technical performance with commercial objectives. This is especially critical for BESS, where cycling, availability, and degradation are directly tied to revenue and long-term asset value. To close the loop, these same data-driven KPIs can be used beyond asset health and also to market strategy. A great example is the market participation optimizer tool that we have on the next slide, which shows how centralized, high quality operational data can be translated into smarter dispatch decisions, improved bidding strategies, and higher overall returns. This tool uses forecasted solar production and day-ahead energy price to optimize the auto bidder strategy. Here, you check the increase in revenue, the auto bidder profile, the battery dispatch strategy, and also charge and discharge evolution. The company strategies are implemented as boundary conditions. So if the system has restrictions such as, for example, a start or end of day at a minimal state of charge, this is taken into account. And also, of course, the physical characteristics are considered, the maximum discharge rate, charge and discharge efficiency, and so on. So the strategy that you see is indeed feasible and realistic, right? When data is centralized and insights are embedded into daily workflows, BESS operation moves from reactive management to proactive value creation. To conclude, we cannot forget data quality, right? Uh, Data quality is the foundation for meaningful KPIs, reliable metrics, real-time insights, and effective centralized asset management. Without accurate, consistent, and trustworthy data, dashboards, alerts, and analytics lose their value and can even lead to incorrect operational decisions. For example, bad data can lead to a bad dispatch, right? If your state of charge reading is off by 5%, your BESS might try to discharge an empty battery, causing a system trip. For this reason, robust automated checks and validation routines are essential to continuously detect faulty sensors, missing signals, and anomalous values, ensuring that all high-level analysis and decisions are built on solid, dependable data. Additionally, it's also important to have redundant sensing and metering. The deployment of backup sensors and parallel meters to cross-validate measurements is key to detect faulty devices early and maintain data integrity for safety, performance, and compliance analysis, right? Okay, now as a conclusion, we'll share some strategies for ROI maximization. Alejandro, please, could you start with some strategies for the design?
Yeah, sure. As Lucas said, every cycle in our battery system cost, and it's really important to note that it's not a common asset like the BESS. The BESS system is going to last for 25 to next 40 years. So every decision that we are going to choose or we are going to make in in the early stages are going to last for a really long time. So aligning design and also operation of these assets is going to be the key for success. So, and this key of success is going to be aligned also with our strategy revenue. Where we are going to get the money from? Are we going to get the money from arbitrage? Are we going to get the money from maximizing the capacity of my PV system? So then I'm gonna choose which coupling strategy I'm gonna use. And then um, also after choosing the right decision of the right strategy of the revenue is going to come from, I'm going to choose also which kind of some ratios that are really important for the designing of my PV system. DC-AC ratio, I'm going to use more panels than the capacity of my inverter. So then rated power is going to help you to compare all these possible scenarios. And also I'm going to maximize the capacity of BESS power compared to energy and the inverted headroom. So depending on this radius is going to also size our solution. Third, all this design is going to reflect in real operation. So having an AC coupling may impact in our operation cost. So it's going to be more OPEX. And depending also on this OPEX, also we have to be aligned with the technical operation team. And depending also on the grid constraints, are we going to be assured that the revenue stream that I chose it's going to flow normally or it's going to assure a constant revenue? So if my country is going to assure some revenue stream such as a grid robustness, so I'm going to take this into account to project all my strategy for long time. So depending on all these decisions and the KPIs that are Rated Power is going to help us to get, all these decisions are going to impact in the decision of the design. And this design is also going to be operate. And Lucas is going to help you out how this operation strategy is going to impact in the life cycle of our BESS system.
Yes, perfect. If I can leave you with a 15-minute ROI to-do list, then here is. First one, review your O&M contract. Does it include state of health, round trip efficiency, and the other KPIs that we mentioned, or just availability? Something to check. Also, digitize your warranty, like stop using PDFs, and move your temperature and cycle limits into an automated alert system. Also, centralize your data. Do you have a single source of truth that consolidates all operational, performance, and warranty critical data across sites? Or is the data spread across multiple systems? Also review your data quality routines. Like, do you have tools to auto-detect data quality issues? Do you have enough backup sensors, or could this number be improved? And finally, keep our KPI playbook close. It is a comprehensive KPI reference which explains what each metric means, why it matters, and how it can guide better operational and financial decisions, right? Designing a hybrid BESS system is the first step, but operating it with the eyes wide open is also extremely important. If you would like to talk more about any of the topics we've discussed or about our solutions to centralize visibility, advanced analytics, and improved operation, please reach out during the Q&A or scan the QR code that we have, yes, in this slide, to book a meeting with one of our specialists. I think we are a bit short on time. We won't be able to address all the questions, right? But also we'll reach out with the answers later if we are not able to answer all of them. And feel free to reach out to us using the QR code.
So now we are open for some questions from the attendees.
Would you like to start, Alejandro? I think there are a few here from the design.
Okay, got it. And just a second. I'm just looking up them. Give me a second. Okay. So there is a question of Vivian Olo. Does RatedPower also show loop in connection from substation to grid? Yes, it's possible to add a substation and also lines, high voltage lines and medium voltage lines. So RatedPower is able to measure all the losses and the energy output just until the point of connection, until the end of the point of connection. So yes, RatedPower is able to address this kind of problems. Lucas, do you want to continue with one of yours?
Yes. Okay. There is a question here. How do I quickly identify which batteries are underperforming relative to the rest of the portfolio, right? Well, Delfos platform has several built-in features for site and peer comparison. So you can easily extract the most underperforming assets or one with the most recurring alarms, for example. You can have either the high-level visualization with KPIs and rankings, but also can go to the bottom of the issues, checking alarms, lost energy, and so on. So you can have the visibility either using the high-level KPIs or also going in depth, exploring all the details of an issue.
Okay, I'm gonna continue with another one that's interesting. Mutachida, in case of grid could tell me how to size the best system, either DC or AC coupling. That's a really interesting question, and it depends really on the price of energy. So if my price of energy is gonna be the same all the time long, so it doesn't make sense to have even batteries. But for sure, at night the price of energy is going to be higher, so then having batteries makes sense. And so you have to compare with the head of RatedPower. It's going to be this curtailment is going to be worthy to store it, compare like the prices at the night. So all these KPIs is going to help you, or I'm going to maximize the 100% of the curtailment. If I'm gonna maximize, maybe I'm gonna use so much batteries. I'm gonna make the most of the PV production, but for sure it's gonna be costly. So maybe going for the 80% of the curtailment, and all this information can get from RatedPower in order to know which KPIs are going to address and to help you out to answer correctly this question. Lucas.
Okay, perfect. And I think probably will be the last one, right, given the time. But how does the platform help maximize battery life and revenue? Delfos platform helps do that as it improves your monitoring, providing real time and also historical KPIs, right, in a centralized manner. So you have full visibility of your entire portfolio. And as you do this, then you can detect the issues early, or check important variables, keep track of warranty conditions as we show using the digital warranty tracker, and so on. The result is that you stay ahead of the issues and you'll be able to protect the asset life, right? Since you are aware of the issues, you can solve them quickly and also anticipate failures even before they happen. So this is how we can improve the revenue and also maximize the asset life, since you stop the problems as soon as they appear. Right?
So thank you everybody for joining us. We are so glad that the topic today got so your attention, and we are here for help you out with RatedPower and Delfos partnership. Thank you for your attention.
Yes, thank you, everyone. We'll try to answer, I guess, all the other questions and share this content, since weren't able to do that right now. But thank you for attending. Have a nice day.
Thank you for attending. Have a